Hello, I'm Jim Frankenfield, and this is another of my problem-solving videos. And this is an interesting problem that was posted shortly after another one, which was on the Georgian national exam. I suspect maybe this was also. And we have two inequalities, and we want to find a parameter so that they only have one solution. We're going to look at two ways to do this, and I may speed up through some of the calculations. You'll need to be comfortable with quadratic equations to follow this video. So let's look at the problem statement and go from there. Okay, so here's the problem. X squared less than or equal to a minus 2, and x squared plus 4x is less than or equal to 1 minus a. And we want to know what value of a will make this true at only one point. What value or values? There may be more than one, there may be one. I guess there could be none in some cases. So let's have a look at this. And the first way I'm going to do this is, I think, the most efficient and quickest way to do it. And computationally, it may be easier. We're going to turn each of these into a quadratic. So we have x squared plus 2 is less than or equal to a. And we have over here, I'm going to multiply this by minus 1. I'm going to get minus x squared minus 4x plus 1 is greater than or equal to a. And I multiplied by minus 1, so I had to flip my inequality sign. So this is a parabola, and this is a parabola. And let's have a look at those two parabolas. This one has a vertex at 0 and 2. And this one will come back to, and I can find some points on here. 1, 3, minus 1, 3. This is just going to help me sketch this. 2, 6, minus 2, 6. So if you have graph paper available, those points, or if you make a grid with a ruler, those points will help. I'm going to complete the square on this one, and I'm going to get minus x plus 2 squared plus 5 is greater than or equal to a. And this parabola is going to have a vertex at minus 2 and 5. Okay, I've shifted x by minus 2 and y by 5. And a couple points on here will be minus 1, 4, minus 3, 4. 0 gives me 1. That's obvious up here. So I'm just going to graph these and then see where they're greater than or less than a. So let's sketch this graph, and let's see. Let's make an x-axis and a y-axis. And actually, this is going to be at 2. This is going to be at 5, and going to look like this. And this one is going to come like this. So these are the two parabolas, and I want to know where x squared plus 2 is this one. I want to know where that's greater than 0, so, or greater than a. So let's just make an arbitrary a here. So here's a, some value a. I want to know where this one is less than a. That's this part down here. And I want to know where this one is greater than a, which is up here. And where they are both true is going to be from here to here. Okay, in that region there, both of those inequalities are true. Where will there only be one solution? Well, there's only going to be one solution when A is down here, when A is up here. And I know that A has to be greater than 2 and less than 5. This actually intersection will not turn out to be at 2, but the parabola ends at 2, so the inequality can't be true below there. And this one ends at 5. The points of intersection will be actually not quite at those points, but we do already have a limit on this value here. So what I'll do is set these equal. So that's how we could find that. If this was on an exam, you wouldn't have a calculator or a graphing program, and you wouldn't be able to come up with these numbers. You would just take x in analytical form, and you'd have to square that and get this. But there you go. There's the answer to that. Oh, looks like I went off the bottom there at the end. So so here's the work I just mentioned. I set them equal, solved that using a quadratic equation, and then I found A. And so I've done that using just paper and pencil that I would have available during an exam. But we're not an exam, so let's have a look at this on Desmos. And here is the graph of the two parabolas. This is blue one is x squared plus 2, the red one is the other one. Here's my points of intersection, minus 1.702 and 0.293. This is where, well, let's put A. Here's A. And here's a label for A. And I can change A. Below 2, there wouldn't be any solutions. And above 5, there wouldn't be any solutions. So I set the slider in there. Here I have a range of solutions. If I want one solution, I need to come up to the intersection. Okay, this is the other inequality. And if you want to see where both of them are equal, it's in the shaded area here. And I could take those away. So that's what the problem looks like. And when you slide A, you'll see that that interval where they overlap is changing, and it collapses to just 1 point at the two ends of that shared interval. So that is, I think, the best way to do that. And now we will go back, and I'm going to do part 2 here. So I'm going to start with a new piece of paper here and be back in a second. Okay, so here we are for the second part of this. And you can, without looking at this graphically, you can look at this as intervals. So I have x squared is less than or equal to a minus 2, and x squared plus 4x is less than or equal to 1 minus a. And this time I'm just going to treat these as inequalities and try to find the intervals where they are equal. So I will find out that minus the square root of a minus 2 has to be less than or equal to x, and that's less than or equal to plus the square root of a minus 2. That's just the square root on, and plus or minus the square root on both sides. If I solve the other side, I'm going to have an interval of minus 2 minus square root of 5 minus a. And you can work out the inequalities here, the intervals, minus 2 plus square root of 5 minus a. So this one is centered at 2, and this one is centered at 0, or minus 2 is the center. So these are the boundaries of the solution interval, depending on A for each of these. So I have here, I have an interval surrounding 0 from the first one, and I have an interval surrounding -2 from the second one. And these could be disjoint, which will happen above 5 or less than 2. In fact, there won't be any. There'll only be one interval. They could be disjointed. They could overlap. We saw a case where they overlap, where there's a range of solutions. They're going to be equal when the two endpoints meet. So when this interval on the right side of this interval equals the left side of this interval, they're going to have exactly one solution. You can try to set the other endpoints equal, but you can see on a number line that that's not necessary or important. It's going to be the right side on this one, which is, let's start, it's going to be the left side of this one. So that's minus square root of a minus 2. That's here. And I'm going to set that equal to the right endpoint here, which is minus 2 plus square root of 5 minus a. So if I solve this, I will have a value or values of a where the two things are equal. So let's just do that. I'll probably speed this up here. You can slow it back down if you want. So here's a quadratic for A. It's quadratic. I'm going to have two solutions. If I go ahead and use the quadratic formula, I will get 7/2 plus or minus square root of 2, same as I did before. And that's for A. I didn't find X this time. Last time I found X and I used that to find A. Here I directly found A. So those are the two endpoints of A. So this time I'm looking at it as an interval. And let's go back to Desmos here, and let's get rid of these things. Actually, I think I'm going to need A here. Let's turn on the slider A. Okay, so and this time I have an interval of solutions. So this is my A minus 2 term. And well, yeah, I added the 0.01 to raise or lower this a little bit. And I can extend that so you can see the formulas. And this is the interval of the other one. And as I change A, you can watch these intervals change here. Here's the slider. So as A gets smaller and it gets down to 2.07, the ends meet, and that's where there's a solution. If I go down to 2, beyond 2, the one parabola has no solution. I can also go up, and they overlap until I get to the upper solution. And at 5, the other one disappears. But just before 5, at around 4.94, should be 4.914 to be exact, the ends meet and I have one solution. So this approach looks at this as the interval of solution. And if you want to just expand that in the y direction, you can do that too. So you can see them overlap, and then at the other end there's one point. So that's it. We found the 2 points, and we looked at it two different ways. First, we looked at it as a parabola and a graph, and the second time we looked at it as solving an inequality and finding an interval of solution or distance. Remember that absolute values and inequalities can be often viewed as distances. So that was an interesting little problem, and that's how you can solve it, 2 ways to solve it. And I will make the Desmos sheet for this video available. I post those links on my website along with the description of the video. So you can find that on jamesfrankenfield.com in the academic library under videos. So you can go there and there'll be a link to the Desmos page for this video, and you can play around with it or modify it or use it for some similar problem, whatever you want to do with it. And if it gets too messed up, just reload the page or close the tab and open it again, and you'll have my original again. Okay, so see you next time. Bye.